In this video, we are going to cover the topic embedded system. So there are 36 slides in this lecture, starting from the slide number 1, Introduction to Embedded System. Let's move to the slide number 2. What are the outline we are going to follow in this lecture? What are embedded system components, embedded system applications, model language and tools, hardware and software, core design and synthesis, real-time operating system, and slide number 3, what is an embedded system? Embedded system, information processing system embedded into a larger product. Two types of computing: desktop and embedded. Non-embedded system, PCs, servers and notebooks. The future of computing: automobiles, entertainment, communication, aviation, handheld devices, military and medical equipment are also considered in this. Let's move to slide number 4. Embedded system, devices other than desktop PCs, servers and notebooks, electricity running through perform something intelligent. Hardware and software which form a component of a larger system but are concealed from user. Computer such as flagged as non-computers. The future of computing. Basically, the embedded system is the future of computing. Let's see the an example of embedded system. There's a camera and there's a chip in the camera, which consists of the following component which you see, which are you see seeing in this slide. There's a CPU, graphic controller, flash, DRAM, memory card, flash adapter memory, IO controller, input output controller, and Ethernet, LCD panel, LCD interface, Ethernet interface, video encoder, video outputs. And these all are in the uh, chip, in the which are there. These all components are in the chip, and the chip in the camera. Let's move to the slide number 6. Next slide. I am not going to make the video long, so we can cover this lecture into two videos. A simplified block diagram. See, this is a simplified block diagram of embedded system. This is AD converter sample and which is this is a AD converter sample and hold, and this is information processing. After that, display and DA converter. Display can be on LCD, which we use on the labs to display numerical values and alphabets. This is after a DA converter it moved to the accurator, and after that it's called move toward the environment, and then sensor then move toward the converter. This is basically a circle which are moving around. It's slide number 7. Course outline. This is a course outline of this course embedded system. The hardware components, concepts, specifications, software component. These all are a mixture which this mixture can are the uh, basic of embedded system. Then next move to the slide. Next slide, components of embedded system. These are components of embedded system: analog computer components, digital components, and converters, A to D, D to A, software. Basically, the analog components and digital components are the hardware, and software is the endpoint. Software is a software. Uh, let's briefly explain. Analog components consist of sensor, actuator, and controller. Digital components: core processor, memories, controllers, switches, application specific integrated circuits, and software consists of application program, exception handlers. Let's move to this bottom slide. Hardware components, which are the hardware components of embedded system. An example, basically this example we also see in the slide number 5, slide number 4. In the camera example, an example which is embedded system. Basically, these are the hardware components which we are going to see in the slide number 10, which are going to see, hardware components of embedded system. An example, these are memory and controllers, interface, CPU is a processor. These are converters. And let's move to the next slide. Processor. What is a processor? Processor controller. Processor is basically a controller and data path. Runs algorithm, and after that general purpose processor, GPU. We can also call as GPU. Variety of computation, task, functionality, feasibility, and low cost at high volumes. Slow and power hungry. Single purpose processor. One particular computation task, fast and power efficient, functional in flexibility, and high cost at low volumes. And this is GP and SP processor architecture. Data input, data path, structure, and then controller, then a controller, and with again data path and data output. We can input data from that side, and then data move toward the controller, and controller control, and after that data path and then output. And then niche move toward next slide. General purpose processor. These are general purpose processors, programmable device used in a variety of application, also known as microprocessor. And features: program memory, general database, general data path with large registered file, and general ALU. User benefits: low time to market and NRE cost, high feasibility. Example: Pentium, Athlon, PowerPC. Application specific IC processor, ASIPS. Programmable processor optimized for a particular class of application having common characteristic. Compromise between general purpose and ASIC. Custom hardware. Features: program memory, optimized data path, special functionality, functional units. Benefits: some flexibility, good performance, side and power. Example: video signal processor, network processors. Application specific ICS. Application specific ICS, ASIC. Digital circuit designed to execute exactly one program. Course for hardware accelerator. Features: contain only the component needed to execute a single program. No program memory. Benefits: fast, low power, small size. And I think this is the last slide, slide number 16 of this of for this video part. Application specific circuit, custom design circuit necessarily if ultimate speed or general energy efficiency is the goal and large number can be sold. Approach: suffer from long design time and high cost. And this is slide number 18, and this is slide number 17, and this is 18. We can skip the slide number 17. You can pause the video and read it by yourself. We will move to slide number 18. This is the last slide of this video, and the remaining slides you can watch from the second part of the video. Storage. What is memory? Artifacts that stores bits. Storage fabric and SS logic. Writability, manner and speed of memory can be written. Storage performance, ability of memory to hold stored bits after they are written. Many different type of memory: flash, SRAM, DRAM, etc. Common to compose memory. Hope you like the video and subscribe the channel, and also watch the second part of the video to cover the whole lecture.